Hello, everyone. Welcome to Next Big Future. I'm my friend Randy Kirk with me. Today is a very special video. I've figured out the future of XAI and Tesla AI beyond Tesla bot. So I've figured out how, what the key application of having the best AI in the world is. How do you make, infinite money really from that thing? So I'll start showing it, and then Randy will give him his insights and reaction to this, I think pretty groundbreaking news, like to figure out the secret.
Okay. All
So
right. Yeah.
I call it AI multipliers,
All right.
right? So it's basically how do we have AI multiply the world economy? What
Hmm.
is the key things you changed? Like it's like if you have an explosion, what is the catalyst, the spark that you're doing that keeps reacting to set everything else on fire and to have it blow up?
Okay.
And so this is the intelligence explosion in detail. So big promises, but let me walk you through all that. So we know XAI Grok 3 is the best AI in the world. Tops the ranks in various categories. It's just ahead of some of the other models based on the scores. And how they did it was that they did with 100,000 GPUs. They now have 200,000 GPUs, but they got 100,000 for the training that they completed in January. And that was a huge deal to build 100,000 GPUs that have shared memory, because this was a big technical problem that other people cannot do. They got stuck at 30,000 NVIDIA GPUs. So this is the Memphis Colossus data center. And then took 122 days to put the 100,000 chips in, fully trained synchronously, and then 92 days to expand to 200,000 GPUs. And I know it's going to 400,000 GPUs in the next few months. Brian, how do you know that's going to 400,000 GPUs in the next 4 months? It's because there is a um, air air resources permit to allow them to pollute with natural gas turbines that they submitted in January through a subsidiary thing, CTC LLC Holdings, and that lets them install 15 of the 16 megawatt turbines. 15
Okay.
times 16, 240 megawatts. So they're at 250 now, add 240 or 490, basically double.
Hmm.
So, and they're buying B200 chips.
Okay.
So they will then install 200,000 B200 chips in parallel right now as they add the power. So they add the power, they add the chips, they turn it all on in a few months, and now they have voila, 400,000 chips.
My one
Okay,
question already,
sure.
I asked you on X, and is this all going to be in the same building?
I believe it's in the same building, yes.
The same building, because there's some rumors that they've got a lot nearby
Hmm.
that they're grading and preparing for
Hmm.
another building.
Yeah. I am not in their buildings, so I can say
Right.
I don't know,
Right.
but I know a lot about AI data centers. AI data centers have very high power in every rack. The fact that I got like, 8 GPU chips in a rack or in a shelf, or if I have several of those, each one is drawing, like if I 8 of them, they're drawing like 10 kilowatts, right? So I only need 1,000 racks to have a megawatt. Sorry, a let me get that right. 10 kilowatts. Anyway, AI data centers are far denser in power. Way more power sucked out of a rack than a regular AI data center. So a regular AI data center would be far sparser. AI data center can have 10 times, 20 times the amount of power. It's why you have to do the liquid cooling and various other stuff in order to keep so much power operating efficiently.
Okay.
And the thing is, if you want shared memory, you really want the same building or as close as possible to it,
Right.
because um, if you separate them, that's what Google's done. They have like 10 buildings. Microsoft is building a bunch of different buildings, each one with 300 megawatts, right? If you do that, you're not getting the shared memory.
Right.
It kind of works. It is not as good as having it all in one building, having them really close together.
Right.
which had technical challenges. I got to put so much power together. I got to put too much heat together. To have it all together has challenges, but it's the challenges that XAI and Tesla are doing, is to put it all together for continuous train memory. Because they're looking at they rewrote the third and fourth layer of the 7-layer Ethernet protocol from software into hardware so they can get to microsecond synchronization, right? So they did this technical challenge, patents, R&D to achieve that. If I'm separating them by buildings, I got to, put InfiniBand and blah, 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 all this connection stuff. And it doesn't work as well. Because
Right.
it's like if I take part of my brain, stick it over here, take part of my brain, stick it in another building, right? Not as good as
Okay.
one brain in one skull.
All right. Okay.
Okay. So we also know that there's going to be Grok Video, Grok 4, and Grok 5. This is from Dr. Alan Thompson, who, is in the know, looped in. So a video where you can generate your own videos, that's coming,
Right.
right? So we got Super Grok coming in a week. We got, which is more reasoning, kind of like an O3 model, better reasoning. And then we got the voice Grok coming out shortly. They gave a little preview of that. Grok Video is also coming soon. I'm suspecting it will be trained up with the 200,000 GPUs that they already got installed right now,
Mhm.
is my suspicion for Grok Video. Grok 4, that's going to be the 400,000, 200,000 H100, H200s, and then 200,000 B200s. Maybe some Dojo 2 initial things. Don't know if they'll be ready yet. Dojo 2 should be coming out this year in volume. Don't know when, right? The advantage of going Dojo 2 versus B200 is Dojo 2 is supposed to be equivalent to a B200. They supposedly have caught up,
Mm.
right? So the big deal there is NVIDIA sells them for about like 4 times the price it cost them to
Right.
make.
Right.
So if I sell it, if I can make it for 1 time the cost, even if it's like only half as good, I'm ahead,
Right.
right? Anyway, so at some point between in Grok 4 and Grok 5, they'll be sprinkling in Dojo 2 chips and then Dojo 3 chips next year.
Mhm.
Okay, Elon has said all you need to know to understand which company will win a technology competition is look for the first and second derivative of rate of innovation. Rate of innovation is everything. Okay, he said that. First and second derivative just means how fast am I improving? I'm faster in innovating. I need to improve faster, and my rate of improvement needs to get faster and faster, right?
Right.
So that's the cycle of speeding up, more speeding up. And then others, Robert Scoble, Microsoft CEO, everyone says, Sam Altman, compute is everything, speed of learning is everything. Again, another way to say innovation and learning, how fast am I getting smarter, is everything. Um, this was from the demo day where they showed a slide showing that Grok 2 had already caught up to the uh, total compute used to train of GPT-4. And they did it, in like a year, right?
Mhm.
If you extend this out, I'm going to show that, Grok 4 is going to be like 20 times higher. Because Grok 3 is 15 times higher.
Mm.
Grok 4 is going to be 600 times higher. Or Grok 4 or 5 is going to be 600 times higher, right?
Wow.
So the again, the curve is going up super duper fast. Okay. And then this is just showing that they're number one in all categories right now and still improving. They're
Right.
doing reinforcement learning, still improving right now, getting better and better still. So not just you train and then you stop, it's like it keeps going. Okay, so I've updated this slide. Oh, this didn't include I have a slightly more updated one as of today. So Grok 4, instead of 200,000 chips, will be 400,000. 400,000 chips, 800,000 GPU chip years of compute, right? Basically like 12 times better than Grok 3, which was 15 times better than Grok 2. And the scaling laws still hold. That was not something else we learned from Grok 3, is that when I get more compute, I'm expecting a level of improvement. We're getting that level of improvement.
Right.
Okay. Okay. So fast power. They're not using these smaller 2.8 megawatt natural gas turbine things. They're using these guys. Again, from the permit application. These are 16 megawatts each. So again, the 15 of these is 240 megawatts. Okay. So I think they get that done in 9 to 12 months,
Okay.
right? Not just the the one getting up to 500 megawatts, adding the 240, that I think happens in the summer. The getting to 9 to 12 is the full gigawatt, 1.2 gigawatts. I say they get that done. They'll have 1 million chips installed. I think B200 slash Dojo 2 chips, right? End of the year. And then you can get off and train. When I train with 40 times the compute, that means what took me a year now with the 100,000 GPUs, I can do in a week, 8 to 9 days, right? So everything goes faster, experimenting faster, everything goes faster. Okay, so as I said, what do you do with this stuff? Complete AI multipliers, right? What do I mean by that? That means people talk about, I need to make a AI researcher, an AI version of a human AI researcher. I need to make a human scientist, an AI equivalent of a human scientist. I need to make the AI equivalent of a PhD, a professor, right? One for one. No, no. I need to make everything for an entire process. So that entire process, the critical path multiplier is going. So a complete labor multiplier is a general purpose humanoid bot that replaces all general aspects of human labor. That is a labor multiplier. So that I put it on 4 shifts, I get 4 times more. Getting that fully perfected, fully multiply is the secret. If I do partially, I'm not quite there. It's not, it can be very valuable,
Mhm.
not as valuable as the full thing. Transportation multiplier, robotaxi, robotruck. FSD, I'm not going to full multiplier, right? It's helping me. It's good. I'm being more productive. Great, better than not the full thing, the full enchilada. Critical path multiplier. So if I have a full data center multiplier, then I can improve the software, the firmware, everything in the data center with an update, right? Boom. I've made even the ones that are sitting there, I get it so that each chip kind of it's 10 times more efficient, right? So then if I've improved that firmware software to that level, right? And people don't know that when you have a computer chip and you have an operating system sitting on top of it, and then you have firmware, and then use Microsoft Excel, so another application on top, going through all those levels in order to make it easy, not easy, but doable to program, right? Operating system, stack it up. I've given up 200 times the efficiency
Mm.
of like being able to work right at the hardware level. You can get that 200 times efficiency back by using AI to do the coding and various other things, right? Like we can't do it. It's like so much effort to, you know, you know, do all design, do all this other stuff, but the AI can do that repetitive work in order to achieve the multiplier effect,
I see.
right? They can fully automate the research, right? So there's all this research on AI, like, the DeepSeek China guys, we figured out how to do a mixture of experts and do these algorithmic improvements, efficiency, lower energy, all that stuff, right? AI can do that, right? Working with people initially, but then unless you get full things where it's like doing all kinds of experiments, how can I make myself smarter?
Right.
Because working on the things that help make me smarter, I would then side jobs would be, improving science and other stuff, making more data, just more compute. You need to have more high quality data. And they talked at the demo about that they made, improvements with synthetic data. So if I have 40 times the compute and 40 times, 100 times the data, good data, useful training data, which you make by taking the existing data and expanding it with statistical analysis, other things, whatever other simulations you do, then you can then continue to get more improvements. In order to get the full power of the compute, you need to have the data expansion. And then you get it so it's learned by itself, where it's like tries to do something, figures it out, reflects on it. They're doing that to a certain extent now with this chain of thought and other things on small problems, but it needs to be at a bigger verification level where it's like, what are the key components for me to make that data center 1,000 times more efficient? How do I make that factory, that gigafactory, 10 times more productive, right? It can be done if you have the amount of intelligence that we're talking about. But it's like, it's a huge lift. It's not just I make one AI scientist that can do one exam. I need to get the equivalent of 100,000 things working together. Just like we have a massive corporation, like 10,000, 20,000 people working at TSMC fab, 1,000 researchers doing, an NVIDIA training. NVIDIA has applied this um, to the fourth line AI chip design. They said at their last reveal of a bunch of new B200 variant chips that they used AI to do the mobile version of B200, a laptop version of B200, right? They did that design with AI. Huge amount of research effort, billions of dollars. But once you master that, then your power goes insane. You would use it to design a better Dojo 3 chip, 10 times better, not better, Dojo 4 chip. You have designed beyond AI 5, which goes into the Tesla bot, an AI 6 chip that goes into the cars and everything. So you bootstrapping your AI with everything. And then you have your mega data centers, which I call that because a million GPUs. They will have that in 2026. So how much will things be better in 2027 if I start to apply AI to improve my AI and to have all that stuff? So I
Okay.
think that's, yeah,
So this is a little bit of what you and I talked about a couple of days ago then,
right, right.
that you basically can start reapplying this back to every aspect of what you're already doing.
That's
So
right.
Tesla might already be way in the lead in terms of the way that their factory uses AI to make systems better, to reduce the number of steps that it takes, or to take out processes and procedures, to use the right metallurgy, et cetera, et cetera. But in this particular case, as you get massive amounts of compute going,
Yeah,
you can just run all that back through the machine again and say, okay, we're using this kind of aluminum, this part on the Tesla Model Y, but we're wondering if there's a way to get some cost out of that aluminum or to make it stronger. It doesn't do well in this kind of temperature. These are the issues that we're dealing with. And you put it back in, and now the computer is so amazing that it can generate approaches and decisions, making, yeah, think about all the opportunities and narrow them down to some right solutions.
right. But it's big super projects, just like, the years it took to make Robotaxi and FSD, right?
Right.
The years in order to get a complete solution with no errors, right? Or with, minimal amount of errors. That is a big difficult thing. To fully close the loop and say, I've got my AI chip design fully done by AI,
Mhm.
right? It's just like making the chips better and better. Things that, we have chip design stuff done using uh, design software, amazing design software, but we have to replicate cores, like, little mini CPUs across, for 1,000 or 4,000 inside each GPU. If you weren't limited by, and the designers can only do so much, they have to copy and paste this over into the design. They have to, even with other stuff, they have to like, in order to make my design of the equivalent, if you expand the chip design up, it'd be looking like 1,000 New York cities.
Mhm.
All
Mhm.
the roads and everything just going everywhere. It's super complicated, right?
Right.
So then you have to take shortcuts into how do I optimize this thing, right? But if I have it fully automated, tireless amounts of AI to do it, right? Then I can get 10 times more performance out of it,
Right.
right? So by going to hardware design, software design, where it's like you go fully automatic, right?
Mhm.
Or, and again, humans may just make the occasional higher level overview decision where they're at, but then it's optimizing by itself, just like DeepSeek did distillation, where
Right.
they automatically had a larger AI train a smaller AI,
Right.
right? That's automatic,
Right.
not like it's doing it automatically. So if you have that kind of like AI helping the other AI and doing stuff, that's when the power just goes, off the charts,
Yeah,
right?
I was trying to use a simpler example for
Yeah,
folks that don't know anything about chips like me.
yeah,
Um, that if you have a simple, I mean, I did it the other day. I know I'm always talking about bicycle water bottles,
yeah,
but I asked it the question that I think you and I discussed on Wednesday night. I
yeah.
said, okay, I got this poppet on a bicycle water bottle,
Mhm.
and some people like a gusher and some people like a sip
Yeah,
when they pull out the poppet. And I said, so what can I do about that? How can I solve that problem? And it came up with three solutions: two caps, two different kinds of poppets,
yeah,
or one poppet that you might twist for a different amount of water. In my particular case, I didn't do it that way. It didn't suggest the third way or a fourth way, which was the more you pulled it out, the more water you get. But it was offered me three solutions.
right, right.
Now, I could have sat around with, five designers and an engineer and 15 other people, and we could have talked about that for a week, and maybe somebody would have come up with all those, but I came up with it in a few seconds.
Right. And then you could have adjusted your prompt to say, I did this fourth way.
Right,
So let's think about, you know, lift, rotation, other variations, and then
right,
what's designable
right.
and what's low cost. So you dig deeper into it. So you constantly iterate and improve with it.
Oh, and
So,
then I would have been able to ask it, okay, we've decided on your method of twisting. Please provide me with a 3D example of that. Then test it.
right, right. And then materials and other stuff, because
Yeah.
I did some work on trying to get a hand sanitizer dispenser during COVID, right?
Okay.
So then we took it to 3D printing stuff like that. So they say, you know, what is the hardness, softness of your plastic
Yeah.
and that kind of stuff in order to get the thing to work right.
Right.
What kind of pumping mechanism and all that kind of stuff. So there's all these details that
Yes.
you would say, one, does it work? And then not having to make a cast in order to make 10,000, make the metal cast and do that kind of stuff. There's a bunch of cost in those steps, right? That you say, okay, do the test, the design works. One, shorten my cycle design time. So I get it right the first time in, a day or 2 days or like that versus, weeks of trial and error. And then, test it and optimize it. No, make it the best one. So all the iterations around going through iPhone 1 to 7, you can just like boom, make the better version, by having that all come together.
Absolutely. Absolutely. Absolutely amazing.
Right.
Okay. All right. I get it. All right.
Yeah. So, but anyways, but the critical path for Tesla and XAI is like there have been for many years in the AI community, they talked about the idea of a singularity and acceleration, right? That you would get to the point where smarter than humans, and then you would accelerate all science, all research, which,
Right.
yes, in general, the principle is correct. But what I'm talking about is what is the critical catalyst? What is the again the spark that sets off the intelligence explosion? Yes, you impact everything else, but what's the most important part? The most important part is the AI data center. The most important part is your models, right? So anything that makes that better means I'm cycling up the exponential faster,
Mm,
right? Going up 1,000 times,
mhm,
10,000 times.
mhm.
What, Moore's law would double every
Right.
2 years. After, 20 years or 15 years, you're 1,000 times better.
Right.
The NVIDIA chips did 1,000,000 times improvement over 10 years. And so they're going to do another 1,000,000 times in another 10 years. Now it can actually go even faster.
Okay, so let me think this through again. So my chip, my 200,000 thing right now is designing my new system. When I get my 400,000, when I put all that together, I will already have designs and concepts that have been created by this previous system that will make it more efficient, that will make it new systems for putting in synthetic, et
Mhm.
cetera, et cetera. But all that's being designed by the system
Right.
before I ever get to the next system. Is that kind of what you're saying?
Yeah, yeah. Or a few multiple AIs, each with the purpose, but very large devotion of resources,
Right,
spending a month of compute time in order for me to get a 10x improvement
right,
in the software of the data center.
right,
So I'm applying this a large amount of compute in order to figure out a really, really hard problem with my best designers,
right,
my best my best technical AI team
right,
of hardware guys and everything else to say, how do we solve a really big problem of making the AI data center 4 times as efficient?
right,
Which, if I just go install more hardware, I can do it,
right.
but it takes me a year,
Yeah,
right? But if I can say I stack on top of that
right,
these other improvements,
right,
so the chips improved, with Intel and everything like that being a million times, a billion times. There were algorithmic software improvements on certain efficiency things that enabled another million times over the last 4 decades. So this is something that happens but this is now automating that algorithm software AI improvement area,
right,
which is with the hardware, get the most out of the hardware. We can get 1,000 times more out of the hardware,
right,
right? We can get um, the models to be 10 times, 100 times, how much more efficient, right?
right.
Maybe we can shrink them down to, um, you know, 1,000 times. It could do the same thing, but just less power, more efficient by, figuring out what to turn on and off, doing that distillation thing. So the amount of gain
Mhm.
that we can get is, you know, like I said, the NVIDIA was talking about a million times improvement in the hardware.
Right, right,
The AI data center, we're going up like 80 times a year, right? 40 times a year. Like we went up 15 times from Grok 2 to Grok 3,
right,
less than a year, right?
right,
We get another 12x in 6 months,
right.
right? So we're looking at already getting up to that innovation rate at 100 times a year just from installing stuff and not being clever, right? But then we get another 10x, 100x from better software, better efficiency.
Sure.
And then next year, instead of just going up 100 times, we go up 10,000 times, right? And so, two 10,000 times leaps might be possible. And then yeah, go ahead.
Okay, so then are you saying the spark, the catalyst,
Yeah.
is the data center? Is that what you're saying?
Right. The data center and the factories, just like they talked about the alien dreadnought for the
Right,
factories,
right,
that is the area where super insane, we don't understand technology is going to happen,
right.
right? It's ground zero for what it is
Okay,
because it's going to it's the AI factory to make the model, to
got it.
make the super intelligence. So I
Okay.
use super intelligence to
To
make
make super intelligence.
super super intelligence,
Right.
to make super super
Yeah,
super intelligence,
yeah,
right?
yeah, yeah.
Right.
Okay, and so and literally, in case I'm maybe wrong on this, the 200,000 that we've got now, let's say that it's going to be months before I got my other 200,000 up and running, but I can ask it questions right now about how to make it more efficient and do an over-the-air update on my existing 200,000 GPUs.
Correct. Right.
Okay.
That would be what the goals would be, that we would improve in place,
Right,
that um, the factory for vehicles, bots, and everything, and whatever else we're making is one of the products, making that better, more efficient, and AI data centers or the equivalent of AI factories, intelligence factories,
right.
are the product to make themselves better.
Okay.
Yeah.
And then would it be crazy to think, because, well, okay, so I have another data center over here. It's a much smaller one. Well, I got one sitting in Fremont, made up of dojos, and that data center is running. And I got this issue for my 200, my Memphis data center. I got this issue that I need solved, but it really doesn't need all the compute that I've got at Memphis. So I throw that onto the one in Fremont and have it work it out?
That's right. That's right. You
Okay.
would want more intelligence everywhere to, just like we have big mainframe computers, supercomputers,
Right,
a bunch of people
right,
working on it, but we're working with our own desktops,
right,
our own servers
right.
to do smaller tests, something like that. We need to enhance the intelligence every step of the way. So smaller, bigger, but the gating factor on how fast the whole company is moving is these really big
Big, big,
projects that really move the big needle
right.
and get you to the next level of different parts, the critical parts.
Now the thing that they're trying to do though at Memphis is they're trying to get this LLM to be max the training, the post-training, pre-training, post-training, et cetera, and now
Reasoning trading and other stuff, yeah.
all that kind of
Reinforcement
stuff.
learning.
So that's what it's spending most of its time doing. But are you able to say, okay, don't do that for a week while I ask you a question about improving your own capabilities? Is that
Right, right. Well, you may also break it up
segmented?
whereas like I would use 10%, you
Okay,
know, 10 times 10%, so 10 different little projects
right,
or 101% project, which is still huge because if
right,
I've got 40x, each one is the equivalent of the current power, right?
right.
So that I can do a bunch of tests and experiments. So you need to do multiple tests and experiments all the time. And
Gotcha.
again, the more overall raw compute I have,
Yes.
the bigger the Death Star, then the more I can do everything. And that goes to the fact that I said, what would take a year, I can do in 8 days,
Right.
right? So that means, each one of the teams could say, got to do another experiment, got to do this, got to do that. Let's allocate some resources to do it. So you can
Right.
split it up and then come together for a 1 month training run,
Right.
right?
Right.
Because um, just pure spinning my wheels to do a big training run.
Hmm.
Instead, I say, let me figure out, where I can make these algorithmic improvements with AI.
Hmm.
And then now we do a completely different kind of training run.
Hmm.
That will be 10 times more productive, right?
Hmm.
So once I know that I've improved my processes, then I go for a training run. So you're sprinkling time in between to it's like Tesla cars figuring out, okay, we're going to take a bunch of time and then, figure out how to make hardware 4 versus hardware 3. We could just stick with hardware 3, but then we cap out, right? So I can make the hardware better. I'm
Right.
going to make, this algorithm better. We had to go to pure end-to-end neural nets, right?
Hmm.
So I had to change entirely what I was doing in order to move forward,
Right.
right? So it's the same, making a new Raptor engine on SpaceX. I have to take the time reinvent everything in order to designing Starship to do landing both parts and then to get again the complete solution to go from the partial solution to the complete. So again, it's like making big steps on innovation means not just grinding a compute thing, but figuring out how to make every step better and then do a big compute cycle, and then maybe you can figure out a way, how can I make the improvements where I could train in place,
Hmm.
where I don't have to swap out my entire brain to learn something to say, okay, now I got to have B200s instead of my H100s. So let's swap this
Yes.
brain, swap that brain, right? I could just say with my current thing, maybe there's some kind of continuous learning, continuous training process, right?
Right.
So
Right.
then it would be again, making everything more efficient. There's ways you can imagine changing how we do things.
Sure.
So that's goes to removing a constraint.
Hmm.
I got faster, but I removed a limitation where I had to do this, and then it costs us, 6 months, a year, me to do this. If I get rid of that constraint, now I can just keep going and going. It just so then it goes to the point of you know, a billion super GPUs that are constantly improving, and I'm swapping things in and out, and there's a continuous flow of just like rising intelligence. I don't have to pop out Grok 4, Grok 5, it's like Grok X becomes the final Grok, and it just like it's like a constantly improving superintelligence.
So now if I'm in control of that, if I'm the guy that's got the best Grok, and
Yeah.
in fact, I'm already working on the next Grok. So I've given you guys all Grok 3, but I'm already playing with Grok 4 and maybe even Grok 5, playing with what that's going to look like. And I have all the compute, and I can turn on this if I want to. I can say, okay, for the next day or two, I want you to work on this. And I want to apply that to a rocket, or I want to apply that to a car, or I want to apply that to a robot, or I want to apply it to FSD. I want to apply it to any of these other things that I'm doing for a day or for 10 hours or whatever it is. That's kind of like hiring all the best engineers out of the all the best universities in the country every single year, year after year, on steroids.
Right, right. And the thing is, Tesla does have more than one car factory, right? You have Berlin, you have Austin, you have Fremont. So having multiple AI data centers still makes sense because you want to do so much. Your application of these things, this is what I want to keep going, right?
Right.
So if I have the money to make more, I want to do that, right? So again, so that goes to the area where um, people say, okay, we're not going to, buy more chips, or it's like, no, this constant improvement in intelligence in chips is insatiable. It's like, when is intelligent enough? It's always better to have more. And if I can get it 10 times, 100 times, 1,000 times a year, I want that, right? So, by 2050, or 2040, we're at a trillion times. It's just like, again, it does go back to the singularity concept, right? But it's like, what am I improving to get to this black hole of change, where it's like it just goes to a world we barely understand, right?
Right, right.
Yeah.
So you have maybe I could think of this as a triangle. I've got these human resources, these brilliant guys,
Hmm.
got this massive computer,
Hmm.
and then we have Elon.
Yeah. Yeah.
I mean, in a way, right?
Yeah.
I mean, he's from another planet. We know this.
Yeah.
Nobody else sat down and figured out how to get those 100,000s GPUs to work together. The
Right.
computer didn't figure that out, and
Yeah.
his brilliant engineers didn't figure that out.
Well, maybe some of them do who we don't know how they contributed. We
We
don't know.
don't know, but we do know that he said
Yeah,
this.
yeah. He was the one who was able to recruit and get the people, and then properly motivate them to achieve that goal.
Right,
And he also goes in terms of like leading them to say, go to first principles.
right.
Let's figure out. Others says it's impossible. I don't think it's impossible.
Never
And
mind. It's not impossible. Yeah.
right, right.
Oh no, I've done. I mean, that's just good leadership. I've done that so many times. And when I
Mhm.
had my factory, it was like, no, we're going to do four color process on these bottles, and they're like,
Right,
nobody's ever done four color process on that kind of bottle before. Well, you're going to.
right, right,
And
right,
6 months later, we did it. So
right.
yeah, you just
So the main thing is like in terms of like beyond Tesla bot is that people think, okay, just replacing labor, that's a huge value. CERN's getting all kinds of valuations on that for shifts, all that kind of stuff, robotaxi, uh, Tesla bot, but it's robo truck. But this constantly improving intelligence inside the vehicles, inside the robots, beyond that, in the data centers and affecting the improvement of the factories, the air data centers, and the world is without limit. It will then, be this wave of expanding touch. And the speed which it could happen is like, not just, you know, you know, 10 times I think the rate of improvement of AI has been about like at 5 times per year, 5 times per year, which is, insane. It's like,
yeah, yeah,
after what, 4 years, you're at 625 times better. So, but now if you start going at 10 times, 100 times, it's just, you know, the, it will be, shocking to see how fast it is. And the thing is, in terms of the Tesla and XAI lead, is that The other guys have to figure out how to install all those chips and make them work at 100,000 level. They have to figure out how to do it. If they're a year, 2 years behind, 3 years behind, that means that they're a million times behind, right?
Oh, I mean, it just, I mean, I don't know if you and I were talking about this the other day, but at this point, I don't see how any of these guys have the remotest chance. Not, not only is it because of this duplicative effect you just talked about, where your better machine is going to be able to help you build a better machine,
Yeah,
but with the skill set, the very important factory building skill set.
yeah,
That includes all the things Elon talked about on that call in terms of, okay, here's where we're going to get the power. Okay, here's where we're going to get the water. Okay, here's how we're going to put the water into the system. Okay, here's how we're going to put these all in a building and hook them all together in 93 days or whatever. There's nobody, there is not another company on Earth, there's not
right.
another human on Earth
Yeah,
that has that skill set. Forget
right.
his brain.
Yeah,
It's the skill set that he's developed now over the last 20 years of how
yeah.
to build a factory that mass produces rockets, mass
Hmm.
produces rocket engines, mass produces implants that you put in your brain, mass produces the robot that puts the implant in your brain.
Yeah,
And not to mention cars
yeah,
and FSD and chips
yeah.
and dojos and everything else.
Right.
Nobody else that has a chance of catching him.
Because like the $500 billion proposed Stargate project, the 5 gigawatt
Yeah.
plant for Microsoft, Ohio, wherever it is, then they have to make the building, they have to get
Yes.
the power, and if they can't even make the building, the power and with water and cooling for 2 years, 3 years,
Right.
then we've already had a 1 gigawatt thing at the end of this year with a million chips. So you don't even have the place to put your chips until for 2 years down the road, right?
And I think that's why Elon said we will never fall behind.
Right,
I think
right.
that's really what it was. It's not just their ability in terms of the chips themselves and what they can do with them.
Yeah.
It's really about what he's always said. The factory is the product.
It also, if you think of like a 100-meter sprint, right? Or, like 4 100-meter relays or something like that. If you've already got up to speed at 60 meters, right? And the
Yes.
other guy hasn't started off the block,
Yes.
right? You're not going to catch up. Usain Bolt is already running, for more seconds. You have a 10-second thing. You get into the point where he's at the 60-meter mark. That took you 6 seconds. He's already done.
He's good. Yeah. Yeah, he's done. Yeah.
So that's the thing is that, the speed of innovation, like in order to catch up, you have to go faster than their rate of innovation. You have
So
to
what
go faster than the rate of improvement.
Right. Well, what I was thinking about the other day is I think it was Microsoft that said we are going to, we're talking to 3 Mile Island, and we're going to have them create this. They're going to go back to their one unit that they shut down. We're going to refire that up, and by 2030, we're going to
Right.
have this nuclear capability to
Yeah.
work on our AI data center. And by that time, it'll be way too late.
Yeah. Tesla will have, XAI will have finished their 1 gigawatt thing at the end of this year, 2025, and they're 5 years late. And then, the cycle of improvement, they'll already be, a billion times better. It's just like, it's like the fact that you physically can't build it. How can I generate something to keep up? It's like I'm going to build my car so I can race you in a Formula One.
Yeah.
You're already down the track.
Yeah.
I'm going to build this car. I'm going to catch up to you, but I'm going to build this car. It's going to be a great car, right? But it's not built.
Yeah. So that goes back to another thing that I talked about in the Elon Musk method in terms of Elon's superpowers. He doesn't go, oh, let's see, how can I get a nuke in here in 5 years? He goes, I need this by the end of the year. How do I get it done?
Yeah,
And I hate to always use myself as an example, but it does remind me of a time when I had a guy leave me. I was shocked he left, and he also owned the equipment, so he took the equipment with him. And all of a sudden, I couldn't produce a single product. I couldn't. There was nothing I could do. And people are like, "What are you going to do, Randy?" The next day, we were up and running. Okay,
yeah,
because why? Because you go, I got to be up and running. And so you don't go, why can't I do this?
Right.
You
Right.
go, what's it going to take? How many
Right.
phone calls do I have to make? How many favors do I have to call in? How
Right.
many how many ideas do I have in the next 15 minutes in order to make sure that I'm up and running by tomorrow?
Right.
And that's how Elon thinks. That's another one of superpowers that people just don't normally think about because that's the regular us the regular folks
Mhm.
don't think in terms of the being able to overcome the impossible. They
Right.
go, well, guess that's not possible.
Right. But the timeline just doesn't work out. It's like, they're already in the lead and they're going faster.
Right.
So what do? I can't even get to the starting line. It's like,
Yeah.
so that's the problem. But so it's hugely exciting. Anything else you had a comment about?
No, I think I get it. I think I get what you're talking about. I see what you're talking about. That again, it comes back to Elon's statement. The factory is the product,
Yeah,
and if you're good at building stuff, then that's going to really help you no matter what you're working on.
that's right. Yeah. Yeah, so it's gonna be an exciting year. So you're already gonna see, Grok 3 video, a Grok 4, 400,000 chips by the summer, 1 million chips by the end of the year. It's insane how fast this is gonna change. So we're talking about, if I'm right, even if they're a month or two late, it's just like the level of change from uh, a model trained with 80 times the compute with possibly 10 times the efficiency
Right.
is mind-blowing how great that's going to be. So, expect change.
Yeah. 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 All right.
Okay. Talk later. Thank you.
All right.